podcast is LG1. So LG1 is just kind of a compilation of the linear graphs and whether you can identify if a graph is a linear graph or if it's a nonlinear graph. Okay, so looking at the notes of what I have here, we have learned that linear functions have graphs that are straight lines. These graphs represent constant rates of change. This occurs when the rate of change between any two data points is proportional. So again, if we were to graph this, it's going to form a straight line on our quadrant. Okay, so we will see that the rate of change, the ratio of going up to over, is going to be constant throughout the entire graph. Now, a nonlinear graph, just like the word says, is a function that do not have constant rates of change. Therefore, the graphs will not be straight lines. So we could have a curved line, we could have a parabola, we could have a circle, we can have a swirl. It would just be a non-linear, non-straight line. Okay, if we are not given a graph to look at, we can identify it through the table. Now, looking at the example of what I have here, you will see that on the x side, we have a constant rate of change. So we're going from 2 to 4 to 6 to 8. So I show my constant rate of change plus 2 off to the left-hand side. Now, on the y side, if it is linear, it will always also be constant. So from 50 to 35, it's going down 15. From 30 to 20, 35 to 20, it's going down 15. From 20 to 15, it is going down 15. So therefore, as x increases by 2, y decreases by 15 each time, the rate of change is constant. So this is a linear function. Okay, so since that rate of change is constant, it is a linear function. Okay, so now a nonlinear function. You'll notice on my left-hand side with my x values, I am increasing at a constant rate of plus 3, plus 3, plus 3. But then on my right-hand side, I'm increasing by 15, then 33, then 51. So as x increases by 3 and y is increasing by greater amount each time, the rate of change is not constant. So it is nonlinear. Okay, so we're really looking to see that these rate of change on our x's and on our y's are constant. Constant meaning the same. So on the second graph, our second table, we do have constant rate of change of our x's, but our y's are not constant. It may be plus, it may be minus, but it has to be constant like what we have over here on example number 1. Okay, so let's look at this graph. This is just set up a little bit differently. It's horizontal instead of vertical. We're going to determine whether it is linear or nonlinear. So again, we're going to look for the rate of change. So from 0 to 5, we have plus 5. From 5 to 10, we have plus 5. From 10 to 15, we have plus 5. So now from 20 to 16, 2016 is minus 4. 16 to 12 is minus 4. 12 to 8 is minus 4. So this is a linear function. Okay, go ahead and try this one on your own. All right, now if we're looking at a graph, okay, determine whether the graph represents a linear or nonlinear function. This one's rather easy. So like I said from the get-go, a linear function creates a straight line. So looking at graph number 3 here, it is a curve. It is not a straight line. So since it's not a straight line, it is a non-linear function. So it is a non-linear function. Again, graph 4, looking at graph 4, it does not form a straight line. So again, it is a non-linear function. Okay, so please do identify C, D, and E, whether they are linear or nonlinear. Now, looking at an equation. So we looked at a table, we looked at a graph, and now looking at an equation. We want to be able to put an equation in standard form. Standard form is ax plus by equals c. So you're going to have your x and your y on the same side and being added. Okay, so we can't have x times y. It has to be addition. It could be adding a negative, which would be subtracting, but it has to be some sort of addition or subtraction between your x and your y. And we have to have it equal a value. So again, a, b, and c are just representing numbers. So I could have 2x plus 3y equals 10. So I can write that as a linear or as a standard form, so that would represent a linear function. Now, if I add up exponent here, it is no longer a linear function. Okay, so for it to be a linear function, we have to have our x value to the first power, which, just delete that off, and our y value has to be to the first power, and we cannot have x in the denominator. Okay, so we have to be able to rearrange the equation into standard form like what I have here. Okay, so let's look at these two examples. Okay, example number 5, we have y equals x plus 4. Can I get that into standard form? Okay, so a couple things I'm looking at. One, I see that neither one of my variables have an exponent. So we're good there. Now, can I rearrange the problem so that x and y are being added on the same side? And I absolutely can. So I can subtract x from both sides. And when I do that, I bring my x to the other side, and it is a positive y, so I would have negative x plus y equals 4. So now it has been arranged into standard notation. And if we identify our a, again, a is the value in front of x, because ax plus by equals c. My a value, the number in front of x, is negative 1, because it says negative. My b value is the number in front of y. It's a positive, so therefore it's a positive 1. Even though we don't see the number there, it's just understood that it's 1. And then my c value, because it equals 4, is 4. Now looking at example 6. Example 6 has x in the denominator. If I were to get x to the other side, I would have to multiply by x. Okay, so that would give me x times y equals 6. And that is not standard form. We had to have gotten x plus y to be standard form. So this one is not a linear function. It is non-linear because we cannot get it into that form. All right, so let's go ahead and identify if this is a linear or a non-linear function. So the first thing I notice is that my y value, there's no exponents to the first power. However, my x has an exponent to the third power. I don't even have to try to rearrange it because x has to be to the first power for it to be standard form. So this is non-linear. And how about this one? Oops. This one, I can get my x to the other side. Okay, right now, again, remember standard form is ax plus by equals c. So this c value, it could be 0. A, b, and c could be 0. So I'm just going to write plus 0 here, just so I know that there's something there. It may be 0, but there is something there. And I'm going to go ahead and bring my 3x to the other side. Right now it's positive 3x, so I'm going to subtract 3x from both sides. So I have negative 3x plus y equals 0. So this one can be wrote in standard form. So my a would be negative 3, my b would be 1, and my c would be 0. All right, and this last one, I want you to go ahead and try this one on your own. So again, this podcast is for linear graphs, identifying if they are linear or non-linear, and also being able to put it into standard notation.